Okay, so next thing is across your research journey, was there a surprising or even funny lab research moment that a student will enjoy hearing?
Yeah, we in experiment we get sometimes surprises. We do electrochemical experiment. We did this one in absence of tube light and one in presence of tube light. It shows difference in their response.
Really?
Yeah, it difference come because there is metal has some roughness and there is a activation of surface plasmon.
Yes.
So surface plasmon does influence the effective work function of metal, and that is shown in the electrochemistry responses.
Okay.
So this is like one way surprise, and so we started doing theory for that. And similarly, like once my student, we were making theory for supercapacitor. So there was some very nice experiment occurred in basically science journal or something.
Okay.
So and they showed that when you have very fine pores in those things, it is like metal carbides. You remove metal there, you will have carbon matrix, and it showed very anomalous property when pore size became very small. So we were doing theory for particularly ion reorganization, and then suddenly the data was showing opposite behavior. So the equation which we derived, my student changed the sign of that equation because it was representing capacity in terms of curvature of the local curvature of the surface, and then data fitted. And while I was having in my slides with the opposite sign, if it did data with different sign, then it occurred to me when I realized, first I was shocked here, we changed the sign. Then I realized this other response is because the curvature which is outside material has, inside material will have opposite sign. If it is convex outside, inside will be concave. So the sign will change there.
Yes.
Then I realized it will be due to some electronic phenomena, like electronic capacitance of my material. So then we started looking into new field of electronic capacitance of material. That helped us a lot because we then could develop many fields out of that. First we did electronic capacitance, then we went to how work function get influence of material by the curvature of the local curvature of the material. It helped us to account atomic steps, roughness on my metal surfaces, etc. In nanomaterials, how curvature influences the thing, how the size and there is a like plasmon activity, so how it is related to that lambda max there. So all this theory emerged because of one mistake by my student, and we cashed on that mistake by realizing this is not coming from my electrolyte solution side, it is coming from the electrode side, and which will make that sign opposite to that, plus becomes minus in that situation. So we looked into theory, what people say about, and we developed like gallium based theory in our approximation, which we have used extensively to explain our electron transfer theories. Potential of zero charge on electrode surfaces for very complicated electrode geometry which nobody has ever touched earlier. So we are able to ask questions which were earlier considered to be tough enough not to touch us. So that was the advantage of this field. Yeah.
Okay, so you find new things by mistakenly and working on them.
So whatever you mentioned, 200 equation, it comes because solving various these kind of problems.
New things, finding
mass transport in rough electrode, porous electrode, electric double layer in rough electrode, porous electrode. These are all very mathematically difficult, so nobody touches that.
Okay.
So we have distinct advantage all over the world to solve this kind of problem.
So
it happens because what I did first when I was doing PhD, I started first building mathematics for this kind of system. That gave me tremendous advantage. The mathematics developed there can be utilized for so many problems actually. There were many approximation, surface roughness based expansion, boundary expansion, perturbation theory, then curvature perturbation theory. So these kind of problem mathematics which we developed, which was not there to how to do it, for electrochemical context. It helps to ask many questions where mathematics we knew we can map it.
Okay. Sir,